In this question, we are going to solve the LP problem and dual LP problem. The question is given below. Make sure right-hand side constraint must be non-negative, so we must divide the constraint by -1. There is no basic variable in the row 1, and we have to add artificial variable in the row 1. Then we also need to give penalty in objective function because there is an artificial variable in the standard form. As we construct initial tableau by using constraint and objective function that given with basic variable a1, s2. For the non-basic variable x1, x2, e1. Before that, we must make sure the coefficient of basic variable in row 0 is 0. After that, we must find new row 0 to eliminate artificial variable in row 0, which is row 0 plus m row 1. As the problem is minimizing, we have to choose the most positive coefficient in row 0 as an interim variable. For the leaving variable, we choose the smallest ratio. And we proceed until coefficient in row 0 non-positive. To make sure tableau 1 is optimal tableau, all basic variable has 0 coefficient in row 0 and no non-basic variable has 0 coefficient in row 0. Thus, LP has unique solution. The optimal solution is x1 equal to 2, x2 equal to 0, z equal to 4.
For the dual LP problem, before we change it to standard form, we convert the LP problem to dual LP. We will have maximum W for y1 minus y2, and the constraint is 2y1 plus y2 less or equal to 2, y1 minus y2 less or equal to 3, y1, y2 more or equal to 0. We construct initial tableau by using constraint and objective function that given with BV is S1 and S2 and BV is Y1, Y2. We choose Y1 as our entering variable because it has the most negative coefficient in row 0. And we choose S1 as our leaving variable because it has the less ratio. Next, we construct ERO for tableau 1. After that, we will have the value for tableau 1. As you can see, all variables have non-negative coefficient in row 0. All PV has 0 coefficient in row 0. Therefore, tableau 1 is the optimal tableau. No NBV has 0 coefficient in row 0. Thus, LP has a unique solution. So, the optimal solution is W equal to 4, Y1 equal to 1, y2 equal to 0.
So in this video, we want to show you how to do the linear programming problem such as we have over here in this document. This problem. Now I'm going to type in variable and we are going to highlight them. Now the variables are x1 and x2. And just to start this off, we're going to make them all 0. Continuously, we are going to type the objective and also going to highlight them. So, the objective is to minimize this example. Now, we are going to enter the function, which is z equals to 2 times x1. And now we are going to click on the cell E5 up here and plus 3 times x2. Now we have to click on cell E6 and click enter, and that's going to be 0. Now I want to add in the constraints. And we are going to highlight it with the same color. There are total 1, 2, 3, and 4 constraints altogether. Now I have typed inequality and right hand side. We're going to do inequality just to set up the first constraint. Start with an equal sign. It's going to be 2x1 plus x2. Click on enter. And the inequality sign, that is more than or equals to 4 in the right hand side. In second constraint, we're gonna enter x1 minus x2. Click on enter. And the inequality sign, which is more than or equals to -1 on the right hand side. Third constraint gonna be x1 with a more than or equals sign with 0 on the right hand side. At last, the fourth constraint is x2. Click on enter. The inequality sign is more than or equals to 0 on the right hand side. Now we're going to go over to a solver on the top. For Excel, click on the data tab. We are going to file to open the solver parameter and going to restore all. For the set objective, I'm going to click on the objective right there and it's just a 0. And here's the $E and $9. We want to minimize this problem, and by changing variable cells are going to be two variables. So I've got to set objective to minimize in this question by changing cells my new variable. Now we are going down to click the add button to add on our constraints. The first constraint right here, and this is a more than or equal to the right hand side, is 4. I'm going to click on add. The second constraint, click on here now. This is a greater than or equal to the right hand side -1. Add. And the third constraint will be greater than or equals to 0. And the fourth constraint is greater than or equals to 0 also. We're going to click on OK. And also we are going to select an option at the bottom. We're going to change the non-linear into simplex LP. And we're going to click on the solve button. Here we have our solution. So the x1 equals to 2, x2 equals to 0, and the maximum value z equals to 4.